Welcome to the third part of exploratory data analysis.
Okay, now we're done with this. As a next step, we can do a correlation plot. Okay, so correlations to house dot core, and if we try to see what the score says, okay, um, this doesn't look that much intuitive. We can try to plot this. Actually, let's make it a figure and acts as plt dot subplots figure size. Let's keep it big. Figure size as 2015. Do some of the things you can Google this up, but what we can do is drop self. Whenever you are trying to do this, you can copy this portion of the code as well. np dot zeros like core. You can drop self np dot into try indices. Try indices. Yeah, try indices. Yes. From drop self, we can keep this as true. Basically, this should be like this. Yeah, this should be like this. We'll keep this as true. Okay, it should be NP. Yep. And then try to do a heat map. SNS dot heat map correlation equals to not correlation post information. We can keep line width as 5 or 0.5 maybe. Annotation equals to true. Format equals to yeah. If mass equals to drop cells and CMap to red you. Yeah, this will do. And finally, we can put a title. Title is what? Correlation plot. Correlation plot. And keep size as what? 50 maybe. And we can keep this plt plot. Show. This will do. Let's try to run this. Good. Okay. So what do we see over here? There is a 0.52 correlation between price and the bathrooms. Okay, let's see some high correlation values. So we don't see a lot of high correlation values. So the highest correlation I can see is over here between the area and price. So as maybe as the price is low, the area is low. As the price is high, the area is high. and as the price is high, the number of bathrooms is also high. Well, this is quite intuitive as well. Like we get to see it in the daily life. Okay, so we're done with this, and what can we do more? We can try to do a box plot. So understand the distribution for most correlated variables like the bathrooms and price. So we can do a SNS dot box plot x equals to what bathrooms and y is equals to price, yeah, and data is equals to house. Okay, I think this will do. Let's try to plot this. Okay, so what can we understand from here? So what we can see over here, the box plots of the three or the four is quite different. So if you see the houses or the houses which has three bathrooms has a very tall box plot, which means the variation in price of this particular houses is quite high, which means some has very low value, a low price, some has very high price. And the box plot of the houses which is one bathroom is quite small, is quite narrow, which means the price of the houses are quite near to each other. Also, what you can see, the box plots median is also quite different. So the houses which has three bathrooms has a higher median than the houses which has two bathrooms than the houses which has one bathroom, which means again it's quite intuitive that the median value of each of these houses with bathrooms is quite different. The houses with just three bathrooms has the median value is quite large than the two than the one. Okay, so this brings to the end of the basic EDA. Of course, there are a lot of things you can do, but I think basically if you follow this, if you do this basic EDA, it will be very good to go. Of course, the data set, the problem changes, and you might need to do something different. But however, I think I have covered almost like 60% of what it should be done. So yeah, let's move on to the next part, which is data preparation.